Hey, what's going on, guys? We have this question right here. It's asking determine the normal force, shear force, and the moment at point C. So let's see how we can do this. So first of all, the first step we have to do is that we have to mention the forces here. So this one gonna have vertical and horizontal force. So let's say this is AY, this is AX, and this is BY. Here we are gonna just have one force. And then if you look at the diagram, we have two unknown here and one unknown here, so and we have to find the C. So first of all, it's easy to find this one because we have two unknown here. So if I take movement around A, I can eliminate these two and find this one. So if I let's see how let's see how we can do this. So if I take movement around A, it's 0 in statics. Then we if I take counterclockwise positive and solve for this one, it's going to be 10 times 1.5, and it's going to be negative because it's pulling this object clockwise. Minus 10 times 1.5, then we have 4.5 times 15, so it's going to be minus 4.5 times 15. Then by is pulling this object counterclockwise, so it's going to be positive 6 by is equal to 0. Then if I solve for by, I will get 13.75 kilonewton. So this is the answer for B, but that's not the question. The question is asking determine the normal force, shear force, and moment force at C. So we have to find the forces here. So in order to find this one, what I can do is I can cut this part off and separate it as a piece. So if it separate this one as a piece, it's gonna have this. I can take this part alone because I know this by already, so I can calculate for others from this one. So if we let's draw this part separately, so it's gonna be something like this, and we are having 15 kilonewton acting in the middle. So the distance is 1.5, and also here we have by pulling this object upside, and since the answer is positive, this the direction our assumption is right. So it's going to be pulling this object upside, so it's going to be 13.75 kilonewton upside, and so normal force is going to be horizontal, right? Normal force is always going to be horizontal, so it's going to be NA, and shear force is going to be acting vertical, so it's going to be VA. And we have to also calculate moment around C. So let's say um, I don't know the direction, I just wrote like this. Okay, then what I can do is let's see what we can find from this one. So if you look at this, we have only NA is the only horizontal force, so I can simply find it's going to be 0 because that's the only force. Let's see. So if I take moment around f of x is equal to 0 and solve for this one, if I take this direction positive, NA is going to be equal to 0 because we had nothing else to calculate, right? And if I take VA, we have two other known vertical forces, so I can find the VA. So if I take sigma Fi equals 0, and if I take upper direction positive and solve for this one, I will get VA minus 15 plus 13.75, and if I solve for VA, I will get, so it's going to be 1.25, so 1 minus 1.25 here. So if we bring it to that side, it's going to be positive 1.25 kilonewton. Since the answer is positive, we know the direction is right. Now from this one, I can find the moment. So if I take the moment around C, these two will cancel, and we can directly substitute this one and calculate. So if we let's say moment around C, sigma MC is equal to 0, and if I take clockwise positive, counterclockwise positive and solve for this one, I will get uh, 15 times minus 15 times 1.5. Then we have 13.75 pulling this object clockwise, counterclockwise, so it's going to be 13.75 plus 13.75 75 times 3, and let's say MC is positive, so equal to 0. You can put negative or positive for MC and you will figure it out after you find the values. So if I find the value, I will get MC is equal to negative 18.75. So from this one I can say this is MC is acting clockwise. So MT is acting clockwise, right? MT is acting clockwise because the answer is negative. The unit is going to be kilonewton meter, and we can write MC is acting 18.75 kilonewton meter clockwise. So this is my final answer. I hope you guys like this video. See you next time.